In this video, I'll be doing the work through for the solution to Skill Builder 11.3, which is based on Charles's law. Now, first of all, we need to look at Charles's law. And Charles's law states that volume of gas is directly proportional to temperature. So what that means is that as the temperature decreases, the volume is going to be directly proportional and decrease as well. So when you think of a balloon that's filled with air and you put that in ice water, it's going to shrink. The volume is going to shrink. And then on the opposite side is if you increase the temperature, put it in hot water, the volume is going to increase as well. So these are directly proportional. From this direct proportional relationship, we can then derive the formula that whatever our initial volume is equal to, divided by our initial temperature, that relationship is directly proportional to our second volume and our final volume and our final temperature. So it's this relationship that we call Charles's law, and we can use this to solve these types of problems. So first of all, we need to identify what's our initial volume and what's our initial temperature. So we have a gas cylinder with a movable piston. It has an initial volume of 88.2 milliliters. So our V1, or our initial volume, is going to be 88.2 milliliters. And our initial temperature is going to be equal to 35 degrees Celsius. And then our final volume is what we're trying to find, but our final temperature, we do know, is equal to 155 degrees Celsius. Now, before we use this formula here, we have to first change over our milliliters to liters and our temperature to Kelvin, and that's because we always calculate we always use this formula with our base units of liters and kelvins. So if we are given measurements in anything other than liters and kelvins, we have to convert back to that. So that's what I'm going to first do. This 88.2 milliliters, I need to get it to be liters, so I'm going to multiply it by the conversion factor of 1 liter is equal to 1,000 milliliters. So in effect, that's taking 88.2 milliliters, times it by 1, and then divided by 1,000, and give myself a little bit more room here. That means I'm going to get 0.0882 liters. So this becomes 0.0882 liters. And then I need to figure out my kelvins. And for kelvins, I have to use the formula that kelvins is equal to degrees Celsius plus 273.15. So if I start with 35 degrees Celsius, add 273.15, my initial temperature in kelvins is 308.15 kelvins. And then I'm going to give myself a little bit more room. I have to do my final temperature, which is 155 degrees Celsius plus 273.15 is equal to 428.15 kelvins. So that's super important. Whenever you do Charles's law, where volume is directly proportional to temperature, you have to remember that your volume has to be converted to liters and your temperature has to be converted to kelvins. Okay, Now that we have our volumes in liters and our temperature in Kelvin, we can go back to our Charles's law, which is that initial volume over initial temperature is going to be equal to the final volume over the final temperature. So that's going to be, our initial volume is 0.0882 liters over our initial temperature of 308.15 kelvins is equal to our final volume over our final temperature, which is 428.15 kelvins. Now, using algebra, I'm going to solve for the final volume. So I'm going to isolate the final volume. And for that, it means I have to take this temperature, bring it over to the other side. And to do that, I have to do the opposite operation of what's happening here. So I say to myself, what is the operation here? It's division. What's the opposite operation to division? It's multiplication. So I'm going to multiply by 428.15 Kelvin. That cancels out. And of course, whatever I do on this side, I also have to do on this side. So if I'm multiplying by 428.15, that means I have to multiply by 428.15. So that's what I'm doing. So to put this into my calculator, I am going to take 0.0882 liters, divide by 308.15 kelvins. Whatever that is, I then multiply by 428.15 kelvins, which gives me a final volume of 0.122 liters. Now the question asks, what is the final volume of the gas in milliliters? So I have to do one final conversion, and that is 1,000 milliliters equals 1 liter. So I will do 122.5 milliliters, because this is actually 0.1225 liters. So when I multiply by 1,000, I get 122.5 milliliters. And that's what the final volume is going to be when I raise the temperature of the gas to 155 degrees Celsius. So I go from 88.2 milliliters, increasing it to 122.5 milliliters, which makes sense because the volume is going to increase when the temperature increases. Thanks for watching. Bye for now.